Alright guys, analysis question 3 has you using the protein data bank, which has you looking for known protein structures. So in this case, what you're going to do when you get to the PDB homepage is you are going to click this search tab up here and do a sequence search. And they've changed this a little bit. Advanced search, sequence search. Okay, and what you're going to be able to do is you're going to be able to paste in your sequence here, and I'm going to quickly grab a sequence for the first PC just so we have an example. Alright, and then you're going to paste in your sequence, and you are then going to hit search, and if you get a match, it will pop up. And to answer the DSAP question, you're going to need to know the accession number, which for a PDB entry is only 4 digits, so 1 EKJ. You're going to need to know the organism, okay, which is right here. I believe this is some sort of P. And then you're going to also have to know a little bit about the secondary structure. So in order to figure that out, you're going to click on the entry and then scroll down a little bit, and there is this column labeled secondary structure with these red and kind of tan boxes here. And you could use that to figure out how many beta strands and how many alpha helices are in it. The red are the beta strands, the tan are the alpha helices. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 beta strands, and 1, 2, 3, 4, 5 alpha helices. And to determine the polarity of these, meaning are they parallel, are they anti-parallel, you're going to have to consult the picture, and I know it's not super easy to see, but sometimes if you open this up, you can swirl it around a little bit and get a better sense of things. Remember that the beta strands are represented by the arrows, and you want to kind of see, are those arrows pointing in the same direction, or are they not? And from the looks of it, we see a little alternating. So this arrow is pointing in this direction, but this arrow is pointing in the opposite direction, and this one's pointing in that direction. So for that reason, I would call these anti-parallel. Okay, so that is question number 3, I believe, asking you to use the PDB database. Question number 4 is asking you to do a TSA search, so transcriptome shotgun assembly, which is basically a way for people who do not necessarily have coding genes to figure out if the genes they have are associated with a coding sequence. This search, unfortunately, for people who do have coding genes is a little bit redundant, but it is good confirmation of the protein that your gene does code for. So in order to do a TSA search, you need to open BLAST-N, so you could get that from the DSAP page, or you could just Google search BLAST-N. You will need to paste in your nucleotide sequence. So I'm going to go back and see if I can easily grab a nucleotide sequence. I'll grab it from here. Copy that. I'm going to paste that in here. And you'll have to change the settings from NRNT, which is the default, to TSA, transcriptome shotgun assembly. And then, of course, you'll have to search for our organism, which is Landultia punctata, ID number 50518, and then you could blast away. And then I believe the information you need is stuff you're familiar with. Let's see if it is on this page here. No, of course it's not going to be in my face, but I think you need the accession number, as well as the name of the organism that it comes from, as well as the length of the sequence. So just a reminder on where you might find the length, okay? Right up here under the title. 1913 are the number of base pairs. The e-value is 0, so it's a perfect match. The sequence identity is 100%. All right, guys. It's installment number 2 on analysis questions. Talk to you soon. Some more analysis question excitement.